No, I thought this. That's Big Daddy's pet pizza. Oh.
All right, so you've got this picture of this parabola.
Upside down parabola.
An upside down parabola. And it says that this is the derivative. So read those kind of questions very, very carefully. That's the derivative graph, not the function graph. So then it says to sketch a continuous function where f of 0 equals -1. So I know 0, -1 is a point on the graph. Sketch a possible graph of the function. And since you now have some knowledge of functions and derivatives, if this is a quadratic, then a cubic, right? And so the places where it crosses the x-axis, the zeros of the derivative are what in regards to the function? The maxes or mins, that's exactly right. So it looks like on here that's about -1.5 and about, let's say 1. How do I know if it's a max or a min? And for these, y'all, I seriously still have to do this. I come here and I go, okay, derivative function, I know where it's 0, -1.5. I know it's 1. The derivative is negative here, which means the function itself is decreasing. The derivative is positive here, which means the function is increasing. And here it's negative, which means it's decreasing, right? So I can kind of get a feel as to what it looks like. So I know it -1.5. This is going to be a minimum. This is going to be a maximum. Just got to go maybe past that a little bit. So minimum, and then somewhere around 1 is a maximum. I know it goes through that point, maybe something like that. This saves me because it's hard for me to envision just looking at the graph, but sign analysis saves me. I hope you can't hear this on the out. That kind of stuff. The maximum or minimum of the derivative is what on the original graph? Yeah, you're right. Point of inflection, right?
In that case, yeah.
And there's only one because I'm concave up, concave down. So somewhere around here, mine's a little off. It should have been over here a little bit more changes. Just with the derivative. Yes.
And maybe also after 32,
Yes.
Wait, are we doing 41 real quick?
Yeah, let me do 32 and I'll come back to just because I've already flipped all the pages. All right, this is 32. So it says find dy dx if sine xy. This looks like an implicit differentiation problem. Does it? Oh, sorry. All right, so let's differentiate. Remember, because we're finding in terms, now when we did related rates, we were finding in terms of t, and that variable was not given in the equation. That's why every variable followed with d whatever dt. This time, if I'm taking the derivative of x, I don't have to include that, right? Okay, but any other variable, yes. All right, so how do you do sine xy? What's the derivative of sine? Cosine. So and now I need to do the chain rule.
But the chain rule is actually doing the
product rule. Now, I can't remember if it was, I feel like it was pre-cal yesterday, so it probably wasn't y'all, but just to let you know, you do realize that this is not multiplied to this and then done the cosine of, right? This is not multiplied to this and then done the cosine of. We do the cosine of x times y and then multiply by whatever this is. In other words, this is not hooked to the cosine there. I could put this in front if I wanted to, right? Okay. So, no. Product rule, derivative of x is derivative of y. 1 dy dx because I'm doing it with respect to x.
It's 1y and then x.
Well, it's just one, so. It's,
Oh, I did the derivative of both. I'm losing my mind. Yeah, sorry. And then x dy dx. Ugh. Yeah, sorry. Sorry. Equals, what's the derivative of 5x? What's the derivative of 3y squared?
6.
Dy dx. Everybody okay? Now I need to get dy dx by itself, yes? Okay? So, let's see. I'm going to probably, blah, this is really y times cosine xy plus x cosine. I'm just distributing this through. Just because I could have divided by cosine xy, but I still got this dx, dy dx on this side. Yeah, I haven't finished. I was explaining this on this part. Now I'm going to move all the terms. You may have done this a different way, and it may be a little bit easier. I'm just doing the way my kooky brain thinks as I try to get these on the same side. So my goal is to get this term and this term together on the same side, and then this one and this one together on the other side. So y cosine, or actually let's put the dy dx's on this side. Let's do x cosine xy dy dx minus 6y dy dx equals 5. Look, it's Christmas colors. Minus y cosine xy. That's right. Factor that dy dx out. Y'all have come so far. I'm so proud. 5 minus y cosine xy. I feel it coming. Dylan's fixing to kill a kitten. I just feel it in my bones. Still there. Noah, what are you talking about? dy dx equals. Did I leave the answer like this, or did I go back in and plug in y? Okay, so understand.
I like making the crazy. Understand what?
That I could have to figure out what y is if I need to write it just in terms of x. I could have to come back up. Y'all probably remember doing this. You hated it. Come back up to the original equation, solve it for y, and then plug that in for all the y's here. Okay. Terrible. Terrible. All right. And which other one? What else y'all say? 25. Just that little rule from yesterday.
28.
Yeah. No, the inverse derivative. You know that one.
I did forget it. Wait, actually, no, you probably should do 21. 21.
I got to post it. It's still on there. I just haven't posted it. I'll post it. It's the one where the derivative, the inverse derivative. But this is actually the y value of the original function because this is an inverse. So if it is like this one, where we know that the point 1, 2 is on the graph. We're given that. We're given 1, 2. 1, 3 is on the derivative, and 2, 4 is on the derivative. If I find the inverse of the derivative at 2, will I find out where's the y2 on the original function? It's when it's 1, when x is 1. So that's what I plug into the derivative. Yeah. You probably have it. That's from yesterday's board.
So that's kind of confusing.
It's confusing, but if you just, yes. The link for this is there. I just haven't posted the recording yet. I'm sorry, because my screen shattered on my computer yesterday. I have a new screen now, though. It's still kind of, my computer's still kind of wonky. It doesn't feel right. Yeah. Nice and smooth.
Yeah, my guy could have done a better job.
All right, which one did you say?
21. No, Miss McGee said you would go back to 21. 21's a hard homework.
I'll do them all, y'all, but you asked. All right, 21. Find all values for of x for which the function y equals square root of 8 minus 5x over x plus 1 is differentiable. Well, we know it's not differentiable where it's undefined, so what point would that be? Cannot equal that. It says find all values for which it is, so x can't be negative 1. We also know that radicals, right, so do what? But because I'm talking about differentiability, and differentiability does not happen at the endpoint because the left and right derivative would not be the same, I'm going to make it that way. Okay, so if I had this, I wouldn't be differentiable at this point. Endpoints are not differentiable, right? So instead of greater than or equal to 0, I'm going to just say greater than 0. Bless you.
That's the graph of the square root. That's the graph of the square root.
Yes.
Oh, yeah, you're right.
Is this not how I did it on the solutions?
Oh,
I feel like it is. Okay. I did the solution.
No, I know, but it's just
It helps to see it worked out. I got you. -8 and then divide by, so x, I got to flip it, 8/5. So I'm going to say it's differentiable on the interval -infinity to -1. It can't be -1, but it can, oh no, 8/5, yeah, up to 8. I hope that's how I explain it. 8/5, it should be 1.5 because it's a calculator. And if you look at the graph of it, no. But look at the graph of it. You know that -1's a vertical asymptote. It's not going to be differentiable there. But here, because the x is negative, I didn't take that into account. It's got a reflection in there too. But it has an endpoint right there. But you'd use your calculator for that. If the limits are the same, so if it's continuous, it's okay. If it's continuous and the left-hand derivative is the same as the right-hand derivative, you're basically looking for points of discontinuity. Discontinuities are not differentiable. Endpoints are not differentiable. Corners, cusps, vertical tangents are not differentiable.
Continuous just means the limits are the same.
This one was calculator, yeah, I apologize.
Continuous just means limits are the same.
corners.
Vertical tangents. What did you say, Dylan?
Continuous means that the limits are the same.
Limits are the same from the left and the right. Yes.
And when so it can be continuous but not differentiable. Right?
Yes.
Well,
A corner would be an example.
Yeah. So this one. So like on this
This
one,
has an endpoint and a vertical
that's an
asymptote.
endpoint right there.
This is what it looks like if you graph it.
You wouldn't include that, right? I guess.
Right. Right. So it's a parenthesis and not. That would be a discontinuity. It's not differentiable. Other questions about that one? If I'd have known that I let you use a calculator on that one. I meant to adjust this so you could see. Sorry.
Well, are we done?
25. All right, well, they're all on the same page. I'll just go in order here. 25. Oh, I remember working this one. Monthly profit. Was this a calculator or no? Oh, okay. I'm good. I'm gonna do my nails like that again. They look so good. I mean, X is the number of pieces sold, a certain artist. Here we go. Graph the function and its derivative, and you can use a calculator.
Wait, but there's only one graph.
Okay, so if you look, the y-intercept is negative 1,500. Did you take your y-axis up and down that far? I don't think so, probably not. I would probably go from 0 to, oh, it tells you the window. Look at the right.
Yeah, it says 0, 15 by negative 5,000.
Go from 0 to 15 on X and go from negative 5,000 to 5,000 on Y. And you should see the picture. And then the derivative also, to graph, I would do that in derivative. If you graph it in that window, there's what you look like. Wait, there. You could either graph using inderiv, or you could find the derivative and then graph.
So how do you know the marginal cost meant to win? Because I
We might have skipped over that.
I mean, I could deal with that. It's like, how do you know that?
Well, actually, I don't know.
I think it's like potato. Not potato. You know when a potato.
I don't know how we missed that. But marginal profit is the derivative.
How in the, is this me on the decimal?
Or, but like that was before the there. But I just didn't know it said marginal. What does margin mean? Margin.
Oh, I must have skipped it last year too, because I wrote marginal profit equals derivative.
Oh,
Yeah. It's such a minuscule topic that maybe one question on the exam that when pushed for time is worth sometimes. It could be, that's why I showed you real quick. But it's so easy. Marginal profit is derivative. So maximum is just the maximum of the function. So now you think back to, right, you think about the zeros of the derivative, you do a sign chart and that kind of thing if you need to. But since this was calculator, you could have just graphed it and calculated the maximum, which is what I did. And then you take that maximum on the derivative, because you want maximum profit, right? You take the maximum on the derivative and you plug that x value into the profit equation to find out what would the profit be. So your maximum profit occurs when you sell 3 1/3. That amount is 648. Yes, this is a type of optimization. I'm listening. You look at the graph of the derivative because it said what is the profit when the marginal profit is greatest. So what is the profit when the derivative has a maximum? Derivative of the maximum, which you already graphed, right? So I'm using my calculator for all this. So I do second calculate max, find this value of the derivative, not the function. That point is 3 1/3, 866. But that's marginal profit. That's not the profit. So then you have to take this value and plug back into the original profit equation. Maximum profit possible. That would be the maximum of the profit equation. Yeah.
Particle, yeah, I don't need.
So that's this point right here. You can find, if you've got a calculator, you can find the max of that. You could find the zero of the derivative. The zero of the derivative is also the maximum of the, you see what I'm saying? So either way you want to do that. McGee.
I knew your name. I was just figure out a question I have. Could we do the particle motion? I know it's gonna suck. Don't be filming me, brother.
Y'all ready for particle motion?
I guess if you wanna make me more impressed.
You can do the maximum of the function or the zero of the derivative.
Wait,
Either one will give you the same value.
You would feel so weird how there's blood in my knee now.
No.
That's like a trampoline.
All right, a particle moves along a line so that its position at any time is given by the function s of t equals negative t cubed plus t squared plus 5t plus 3, where s is measured in meters and t is measured in minutes. MM. Yeah, you will. Okay. The first one asked me for displacement. What does displacement mean? The change, right? How much it actually traveled, not taking into account, right. So if it says the displacement during the first 4 minutes. Yes. You don't even, well, you're not looking at an average rate of change. Displacement just means how far did the bug move on the ruler? Okay. So when I plug in 0, I get 3. Well, that just means that on my little ruler, the bug started at 3. That doesn't mean he's traveled 3. That means he started at 3. His position is 3 meters. And then at 4, what do you get, 64? I don't know. Somebody plug that in and do it.
Wait, so Mr. D, if he starts at 3, why don't we call 3 0? No, I'm just saying, like, if he's starting at 3, is he really starting at 3 or is he starting at 0?
No, at 0 seconds he's at 3. So if I'm on this ruler, right, and this is the middle, this is 0, 1, 2, 3, right? He drops down out of outer space right here on the 3 point. And then he starts walking.
I don't know why that matters. I don't know why they would.
Well, because it's not necessarily, if this is my position.
So you're legitimately saying in this problem, he's falling onto a ruler.
Yeah.
So you're gonna plug in 4 in that equation.
That's my bug. It's a bug. Trust me, it's a bug. He just is pre-smushed. Okay. So now at 4 seconds, so this is where he starts. Start, even though this is 0. Okay. At 4 seconds, where is he? Well, at 4 seconds, negative 64 plus 16 plus 20 plus 3. What do you get? Holy crap. Okay. Pretend so dot dot dot. Well, he's a confused little bug. and this is where he ends up, right? So how far did he actually travel?
Or, so the displacement would be -28.
Or is it just 28?
I think it's just 28.
It's minus 28. You may, well, what if you said you moved 28, like if you wrote it out, it's different than saying negative 20.
Wait, what?
Is it positive or negative? It's negative. And then that displacement. But that's not average. And you find the average of what kind of bad word for.
What is our displacement here? We subtract, so it's ending position minus the starting position. So -28 or -25 minus 3, which would be -28. So it's end minus start, if that helps you. What?
What average?
All right, average velocity is a rock.
But it says on the first one that's
So but it's don't take, this is where there was some confusion yesterday, okay? Don't take the derivative of the position and then don't do that, because then you're finding an average acceleration. A rock is an estimate of the derivative, okay? So the average, this is a rock of position equals velocity. Correct, that's right. We want the average rate of change. The average rate of change of position gives us velocity, or estimates velocity for us. So I take these same, is it still first 4 minutes? So I take 0, 3, and I take 4, -25, and I do the slope between them. Now, ironically enough, what do you notice about the top there?
It's going to be.
It's the displacement, right? Now, do not forget here, and I forgot in this one, this is meters. I'm telling you, there are times on the AP exam where there is an FRQ, and even if nothing else is right, if you just wrote like 25 meters per second, you would get a point for the stinking units.
So I can write some random number.
Just for knowing that that's what, never leave anything blank. Write something. Take a derivative, write a unit, write something.
So we're doing with displacement. So basically we found the displacement and it was -28, and we found that when we did A rock it was positive.
That's right. All right, part C. Find the instantaneous rate of change when velocity is 4. This is derivative. Okay, so I rock, so S of t, not double prime. S of t would equal the velocity, which equals -3t squared plus 2t plus 5. I hope we can all do that in our sleep now. So at 4 meters per
No, you do power rule first.
No, wait, what? No. Here I go listening to you again.
All right, look.
4 squared is 16, and 16 times 3.
Well, we're not doing it. Let's get it rid of it. That's already what you're doing.
What? Why are you power ruling anything?
Okay, that's what I was asking.
All right, 16 times 3, 48. That'd be negative 4, so that's negative 35, right? That'd be negative 40. This is meters per second. Look at the difference here. Oh, it is, sorry. The average as opposed to the instantaneous. Was that bug ever traveling at negative 7 meters per minute?
It had to have been, yes.
Why?
Yes,
Why?
it was. Because of something.
You're getting there, you just don't know the
Wait,
name
it's
of it,
the
but you're
theorem.
the intermediate value theorem, right? Between any two points, the average rate of change, somewhere in there, it hit that velocity. Good job, y'all. I always think about the speeding, the lady that was speeding that said, how do you know that I got hit that speed? Yeah, the wrong one. All right, part D. Find the acceleration of the particle when t equals 4. Right. So the second derivative of the position, which is the first derivative of velocity, which is the acceleration, which is negative 16 plus 2. What is, whenever it's 4? That would be negative 24 plus 2. What's your unit? That's right. At 4 seconds, is the bug speeding up or slowing down?
Now we have to look for a sign for the.
I'm just asking you.
Wait, say that again? It's speeding up, put the sign.
You got it.
The signs are the same.
Okay, velocity and acceleration. Signs are the same, speeding up. Signs are different, slowing down. Yes, write that down.
Yep.
So my little bug is getting faster and faster and faster. Velocity and acceleration at a particular point.
They're both negative.
Correct. And that would definitely be a question that was asked, and because they're both negative, you would think, oh, they're slowing down, but they're not. Right. So it's not. It's not the case. It's just moving backwards. And that makes sense on my ruler there. If he dropped down at 3 and ended up at negative 25, he's moving backwards. Good. Where does it change direction? So what does that mean?
You didn't know when the velocity is 0.
That's exactly right. Because, and if you think about it, now that we've done so much work with derivatives and everything else, if you think of this instead of as a particle, but if you think about it just as a derivative and a function, when does the function itself change direction? When the derivative is 0, right? So I take the derivative. Where's my derivative? There it is. So I take the derivative.
Is this a quadratic question?
No, this would not be calculated. And I want to know, where does this equal 0? Well, I'm going to factor out negative 1 first, because I do not like. And now I factor. What multiplies to negative 15 but adds to negative 2? Negative 15.
5 and 3.
Okay. So you multiply the first and the last together. I do too. You multiply the first and the last together. What multiplies to negative 15t squared, but adds to negative 2t. So instead of this being negative 2t, I'm going to write it as negative 5t plus 3t, because that's the same thing, right? And then I can split it up. Take out a t. No. Take out a 1. Now I'm good to go. A 1 because it didn't have a GCF there. Why didn't you use the other one, Aaliyah? It'd be a negative time, and that doesn't apply. My time is always positive. So at t equals 5/3, it should be changing direction. It didn't ask me to justify or verify or anything of the sort, and so I just know there. Maybe I should do a little sign chart to make sure that it doesn't, because remember, it could just stop right there and rest. Noah, 28. You're very welcome. dy dx if y equals 2 sine. Where'd you do product? All right, let's see. Dy dx. Let's do quotient. Derivative of the top. My,
Literally, I can't even do the column. One.
I'm sorry. Get a separate paper, man. It's almost time to go. All right, derivative of the top times the bottom minus the top times the derivative of the bottom. What's the derivative of 5? Don't have to worry about it. What's the derivative of secant x? Secant x tan x. But it's a negative. I don't need a chain rule here because it's just x, right? Is everybody okay there? Well, if it were an FRQ, you could. But I want to show you how to manipulate it if this is a multiple choice, because this one would be a multiple choice question. So I'm going to go ahead and make this look a lot worse before I make it look better. So stay with me.
Wait, why couldn't you cancel this? You couldn't cancel.
Don't.
I just said.
No, I'm just saying it's not being added.
You just want to kill a kid, don't you?
No, I'm just saying.
This minus is not enclosed in parentheses, so I can't start marking anything out yet. I could break it into 2 fractions and cancel, but then it may not help me in the end. Yeah. Let's keep it in 1 first and see what happens. All right. This is going to be 10.
10 cosine x minus 2 cosine x.
All right, now wait a second. Secant x is really what? Does everybody agree with that?
No.
So what is cosine x times 1 over cosine x? 1. So 2 cosine x times 1 over cosine x is really just 2. Because this 2's out in front. So cosine x times 1 over cosine x is 1, but I've got to remember that 2's out there. I'm multiplying by 2. Minus. Actually, it's going to be plus because of these 2 negatives. Around what? Around what? Oh, if you want to. Okay. I am going, and I will tell you, this is where pre-cal is struggling whenever we get into the trig, okay? And my advice to you is, as you are simplifying down and you don't know what to do, try your best to write this is only a simplification, not derivative stuff. Try your best to write everything in just sines and cosines. In other words, tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. Those 4 little things will help you immensely. Okay? So in other words, secant is the same thing as 1 over cosine. Tangent is the same thing as sine. Oh, maybe it won't help me here. Maybe I lied. But okay.
Oh, no, you can cancel out a sine.
So really, this is the same thing as sine over cosine squared. Do you agree with that?
Yes.
Times a sine.
Then it would be sine.
So I've got this 2 out here, so it's going to be sine squared x over cosine squared x.
It'd be tangent squared.
That is correct.
So when we get this part and we misplace the square, I put a square behind that x. Does that mess up the entire problem?
Unless it was cosine x and a parenthesis like that.
Then what?
If you just wrote this, that would be wrong. That would be, yeah. Because this is squaring cosine. This is the same thing as cosine squared x, but they do not equal that. All right, let's see what we got. 10 cosine x minus 2 plus 2 tangent squared x.
Yeah, on the bottom you don't do that.
A lot of times you don't, because in general, completely factored is as simple as you get. And that's completely factored. The only thing I see that I could do y'all remember whenever we did rational fractions in Algebra 2, and I said, expand it out, get it as big as you can get it, and then factor it completely down, and then you'll know when you're done.
I remember you remember that.
So it's kind of the same concept here. If it's already factored completely, back off and leave it alone. Okay? This was factored completely. The top was not, though. This is not factored completely. I could do something else with it. And in this case, I could take out a 2 if I wanted to, and have 5 cosine x minus 1 plus tan squared x. You don't necessarily, it doesn't do me any good here, but you really just want to work it as much as you can, because, again, sometimes you're just trying to manipulate yours to look like one of the answer choices.
Where did you get 5?
There was a 10, and I factored out a 2. What? I mean, raw score you could.
Is it going to be a scan?
Probably not. With just 11 of y'all, I can grade them pretty quick. Yeah.
Oh, yeah. Thank you, Wyatt. Logarithmic.
Oh, I thought y'all liked that.
Hey, what? Is that going to be on the test?
Hey, mate.
Everything's game. I literally, when I tell you, I took an old AP exam and I deleted any type of integration off, because at this point, anything up until integration is game.
Integration might happen whenever the black and white are together.
Which one are you working through?
Oh, God, I hate
It was what? I'll do one of them, star one of them, and as soon as I finish this one, I'll do. Well, do you understand what you did?
Last night's parents.
What was last night's Barron's on? Just taking derivatives? We'll do this. Y'all send me a list of numbers that you would like me to work out like a step-by-step, my solution for in Barron's, and I'll do that for you and have it by tonight. Do what?
I'm not doing that.
You don't have extra ones tonight. It stopped last night. Tonight's a catch-up night. All right, so this said use logarithmic differentiation, so I'm going to take the log of both sides. The reason we do this is because with log properties here, I can bring this around the front.
Yeah, I remember that.
So I've got the log of y equals x times the log of sin x. Now what? This is, right, 1 over y dy dx, right, because I took the derivative of y there. It's not just, if that was just a y there, I could just put dy dx equals. But because it's a lot, there's a function attached to it, I have to do the dy dx. Now, chain rule, I mean not chain rule, product rule. Derivative of the first, you can't just take it out.
Oh, we're going to have to do chain and product rule.
Times the second plus the first times derivative of the second. Oh, yeah, no, wait. 1 over sine x times cosine x. It's the derivative of a log is log blah. The derivative would be 1 over blah times the derivative of blah.
When you get bounced out to it, calculus really is an extremely difficult.
I'm going to multiply both sides by y. Do you think so?
But really,
But I think that so much of it is not the calculus that's hard. It's everything preceding it that you're supposed to retain and know.
You're supposed to retain it, think about how much that's. It's just
I know, that's why it's hard. It is. You're exactly right. It's where all these math classes you've learned it and you spit it out on a test, and now it's like, okay, now remember that, now apply it here.
Yeah, well, you have a small brain like yourself.
I've got the log of sine x plus, I'm going to go ahead and make this cotangent just because I like things to be as clean as possible. That way, cosine over sine would be cotangent. Just because I am going to have to go back now and plug in for y. Because but you don't want a y in it. You definitely don't want a y in that. And look, it's a multiple choice question. None of the choices have y's in them. So what does y equal? Go back to the beginning. Y is sine x to the x. So dy dx.
Oh, yeah, it is.
I didn't realize this was a multiple choice. Do they have the answers in cotangent or no? Let me
Are we
look.
talking about like capital D?
It seems like it's D.
It is. It is. It's D. It's D.
D, as in D.
No, what sign's wrong?
Oh, it's backwards.
Yeah, they're just switch places.
Oh, that's just plug in for
Yes.
Thank you, Mr. Duvall.
You're very welcome. It's kind of my job.
Yeah, well, it is.
I mean, a little bit. Just a little bit, though,
At
right?
least you enjoy it.
How do you know I enjoy it? How do you know I enjoy it? I'm just kidding. Okay.
You told me that you enjoy it. You act like
Extended function here. Oh, I'm hesitant to.
Wait, which number?
This is where we plug the hole. number 16. So that it's continuous at x equals 2.
I had to do this one. I selected 2, or maybe 2, and that was not right. You have to factor.
It's, huh? Okay, so factor top and bottom. All right, so I've got, and these don't have coefficients in front, so they're easy factors. X plus 2, x minus 1, x plus 5, x plus 2. So the problem is that these cancel, right? But I want it to be continuous at x equals 2. So what I do, once I get it canceled out, then I take this, which this is not the actual equation, right? But canceled out, I've still got a hole at 2. If I gave you this, I would still have a hole at 2, even though that cancels out. So to plug the hole, I say, well, let's let f of x be this everywhere except 2.
But no, I'm pretty sure there's a different way to plug the hole.
But when x is 2,
I learned a different way to plug the hole and freak out. I think when
oh,
we
it's
did it,
negative 2.
we just put it back into the thing.
We just had
Negative 1.
you had like the entire first equation and that second equation. Like x is not equal to
So this, oh, you can do that too. It's going to end up giving you the same thing. Yeah, you can also do it like that. It's the same thing. I had it like that. Let that be the equation when x does not equal negative 2, but then let negative 1 be the equation when x is 2. That, where that is, that works too, either way. All right, what else? If you have any pressing questions, text me or email me. Don't make it be super late though, because